This video is going over the opener from lesson 1.6 on simplifying trig expressions. So the first question is asking you to find the cosine of 5 pi over 6. I'm going to draw a little sketch of where that is on my unit circle. 5 pi over 6 is approximately there. The cosine is going to be my x coordinate. And if I think about where that would be, it's going to be negative. And it's the long side of that 30, 60, 90 triangle. So it's going to be negative root 3 over 2. This next one here is the tangent of 7 pi over 6. 7 pi over 6 is right there in the third quadrant. And that ordered pair, the x coordinate is going to be negative root 3 over 2. And the y coordinate is going to be negative 1 over 2. So if the tangent is y over x, I'm going to take my y value and I'm going to divide it by the x value, which is going to be, I'm going to keep my first fraction the same, and then I'm going to do the reciprocal of the second fraction. And then I'm going to try and simplify that. So the two 2's would cancel. My negative times a negative is going to become positive, and that's going to give me 1 over root 3. But I need to rationalize that. So I'm going to multiply by root 3 over 3. And so the tangent of 7 pi over 6 is going to end up being root 3 over 3. The next one, I'm going to find the sine of 11 pi over 6. So 11 pi over 6 is approximately there on my unit circle. The sine is the y coordinate. I can see my y coordinate here is going to be negative, and that's going to be the short side of that 30, 60, 90 triangle. So it's negative 1/2. The tangent of 3 pi over 4. 3 pi over 4 is right there in the second quadrant. And again, tangent is y over x. And at that point, my x and my y value, my x is negative, my y is positive. So I know my tangent is going to be negative because I'm doing negative divided by, I mean, a positive divided by a negative, which is negative. But the coordinates, the actual values are the same. And so if I divide root 2 by root 2 over root 2 divided by root 2 over 2, it's going to just give me 1. And so anytime you have the tangent or the cotangent of any of the angles that are over 4, it's always going to be either 1 or negative 1, depending on the signs of the quadrants that you're in. All right, this next group, we have angles that now are not, this is not on the unit circle, which means that we're going to be wrapping around more than once. So the easiest way to do that is to think about 4 pi and subtract 2 pi from there, which is just going to take you to 2 pi. You can also think about it visually. I'm going to go around 2 pi, and then I'm going to go another 2 pi. 4 pi is going to take me to that point there. And the cosine along the positive x-axis, that's the 0.10, and so the cosine is going to be 1. And so the cosine of 4 pi is also going to be 1. With this one here, this is a negative angle, so that means we're going to be going clockwise instead of counterclockwise. There's a few different ways you can think about that, but you want to take that angle and add 2 pi to it. And I'm going to rewrite that with a common denominator. So I'm really adding 12 pi. And so if I have negative 13 pi over 6 plus 12 pi over 6, sorry, that's going to end up giving me negative pi over 6, which is still negative. So I'm going to need to do it again. If I add 12 pi over 6, that's going to give me 11 pi over 6. So this ends up right there in the same place as 11 pi over 6. Again, you could also visually just think about it. If I went around clockwise pi over 6, 12 pi over 6, and then I went another pi over 6, that would take me to negative 13 pi over 6. So this is going to be essentially the same as the answer for number 3, because it's taking me to the same place. And so this is going to be negative 1 over 2. Tangent of 11 pi over 4, 11 pi over 4 is more than 2 pi. So I'm going to do the same thing I did in number 5, and I'm going to subtract 2 pi. I'm going to get a common denominator here and multiply by 2 times 2. So this is going to be 11 pi over 4 minus 4 pi over 4. When I do that, I'm going to get 8. I'm sorry, I did that incorrectly. That should have been multiplied by 4 over 4, which is going to give me 8 pi over 4. So when I subtract 11 pi over 4 minus 8 pi over 4, that's going to give me 3 pi over 4. So if I now think about where 3 pi over 4 is, it's the same as question number 4. It's taking me to the same place. And so that is going to the tangent of 11 pi over 4 is equivalent to the tangent of 3 pi over 4, which is -1. The next one, we have the cosine of 16 pi over 3. 16 pi over 3 is more than 2 pi. So I have to figure out where that is on the unit circle. Again, I'm going to subtract 2 pi. I'm going to get a common denominator. I'm going to multiply by 3 over 3. So that's going to give me 16 pi over 3 minus 6 pi over 3. And that gives me 10 pi over 3. Well, that's still more than 2 pi, so I'm going to do it again. And then that ends up giving me 4 pi over 3. So this is going to be the cosine of 4 pi over 3. So 4 pi over 3 on my unit circle is right over there. And again, cosine is the x coordinate. I can see my x coordinate is going to be negative, and it's going to be like the short side of that 30, 60, 90 triangle. So it will be -1/2. The next group are our reciprocal functions. So we have cosecant of 5 pi over 6. So again, I'm going to just draw my little sketch here. 5 pi over 6 is right there. The cosecant is the reciprocal of the sine of 5 pi over 6. So I'm going to figure out what the sine of 5 pi over 6 is. Again, you can see it's negative. It's positive in this quadrant here, and it's going to be equivalent to that short side. So the sine of 5 pi over 6 is 1 over 2. And so the secant is going to be the reciprocal of that, which would be 2. For the cotangent of pi over 3, cotangent is the reciprocal of tangent. Tangent was y over x. So the cotangent is x over y. Pi over 3 is in the first quadrant. The ordered pair here is the x coordinate is 1/2 and the y coordinate is √3 over 2. So if I take 1/2 divided by, that's my x coordinate, divided by my y coordinate, I'm going to simplify that, and that's going to be 1/2 multiplied by the reciprocal. And then I'm going to simplify this. The 2 2's would cancel, and then I need to rationalize the denominator. So I'm going to multiply by √3 over √3, and my final simplified solution would be the square root of 3 over 3 for the cotangent of pi over 3. This one is a reciprocal, but it also has a negative angle. So again, you could think of it as if you do -5 pi over 6, that's going to take you to the same place as 7 pi over 6. If you don't see that visually, you could also take -5 pi over 6 plus 2 pi. Again, you want to get a common denominator. So you're really adding 12 pi over 6. If you add 12 pi over 6 to -5 pi over 6, that gives you 7 pi over 6. Sorry, 7 pi over 6. And so it's going to be approximately there on your unit circle. The secant is the reciprocal of cosine, and the cosine is -√3 over 2. And so I'm going to take the reciprocal of that, which would be -2 over √3. We're going to need to rationalize that. So you would multiply by √3 over √3, which would equal -2 √3 over 3. And the last one is -13 pi over 6. Again, we want to figure out where that is on the unit circle. So if I take -13 pi over 6 plus 2 pi, I need to multiply by 6 over 6. It's going to be negative 13 pi over 6 plus 12 pi over 6 is negative pi over 6. I would need to do that again. This might look familiar because we already did it back here in question number 6. So again, if we add 12 pi over 6 again, it's going to equal 11 pi over 6. And so this on the unit circle is right there. That's the ordered pair. The x coordinate's √3 over 2, and the y coordinate is negative 1 over 2. So if I'm doing cotangent, cotangent is x over y. I could take the x coordinate, which is negative 1/2, divided by √3 over 2. That's negative 1/2 times the reciprocal of this, which would be too many mistakes in this one.